Hello everybody, Bob Giller here for another video, DIY video, and this one involves my motorcycle trailer that you can see behind me. And it's such a beautiful day, I want to take advantage of it and work outside. So I've been thinking about this project for a little while now, and motorcycle season's here, so I want to get it ready. So what we're going to do to my trailer on this project is to upgrade the interior lighting system. So let's take a closer look at my trailer. It's a 7-foot by 12-foot motorcycle trailer, enclosed. You can carry anything if you wanted to. I get the chocks in here, as you see. I've outfitted it with my gear. It's been on several trips with me last year and the year before. So one thing I've noticed is that when we're out on the road and we're camping and it's dark out, there's no interior lighting in the trailer except for this one. And unfortunately, this one will only work if I'm connected to my tow vehicle, my truck. So without that, I get nothing. I'm in the pitch black. So using flashlights, which is very irritating. So what the project is going to involve is putting some LED lighting on these cross members, and putting some switches on the wall here to control them both from this side door and from the rear, so it's convenient to turn them on and off, and to install a battery system to support the lighting when I'm not hooked up to my tow vehicle. So trailers like these come wired and configured with all the lights you need, brake lights, turn signals, all those types of lights, running lights, and they're all operated through this hookup here, this electrical jack here, hookup, and that plugs into my truck. So in addition to that, there is a battery here, one battery, and this battery is intended to operate the emergency braking system in the event that the hitch gets disconnected from the tow vehicle. These chains here would keep it connected to the truck. It would pull this ripcord out and apply the brakes full power. I have electric brakes on this using this one battery right here. So when we talk about electrical systems for auxiliaries like lighting and other things, then you really have to add that a completely different system so that you don't tie into this one. And that's what we're going to do for this project. So I pulled out the electrical schematic for this trailer, and you can see it here. And here is the electrical cord that goes to the truck. Okay, and then you can see this buzz bar here. It just passes through all the signal lighting to the trailer here. Now down here is the emergency braking system. Here's the battery here. Here's the controller. Basically, it's just a charger. This controller just charges it up using the battery in the truck or the charging system for my truck. Okay, and then here is this switch box which has the ripcord on it that will activate and energize the electric brakes here when it's pulled. So that's the whole system. We're not going to play with that system. We're going to leave it alone. What I'm going to do is I'm going to tie in another battery, which I schematically drew here. Matter of fact, I'm going to do two. Here, 20 amp hour rating. I have two 10-hour packs. And basically, I'm just going to tap into the same black wire that comes from the truck alternating system, the charger. And that's going to now power or charge up my battery for the auxiliary lighting. And then is a white that goes back there to the neutral. And then the blue, which comes out of this battery box, is then going to go into the black in my harness in the trailer to energize the circuit for the dome lights. And that's the circuit I'm going to use for the lighting. That's the current circuit being used for that side dome light that I showed you. So we're just going to tap off of that one and expand the lighting on that one, the load on that one. Now, I also did some calculations here. So I went out and I bought this very nice high quality LED tape from LEDsupply.com. It's a good quality waterproof tape. The specs on this tape is that it draws about, it consumes about a little over 14 watts per meter. It's a 5-meter strip, so it's about a 72 watt load on the system. And if you divide by 12, you end up with 6 amps. So that's what we're dealing with here, 6 amps. So that's important information because now I can size my wiring. And I kind of did that here in this little schematic here. So you can see that I'm going to use a 14 gauge, a 2 conductor 14 gauge wire between these two switches I'm going to install. And then I'm going to use a 14 gauge coming down from the power feed on that black wire, this one here, which is a 12 gauge, I think, wide with a trailer. And then I'm going to reduce it to an 18 gauge once I go between the LED strips, because I'm going to cut this tape into 3 different sections and then connect each section electrically. So then if you think about it, 6 amps divided by 3 is 2 amps each, so we can go down to a lower size. And that's good, because this tape, when I connect it, really can't take a high gauge, a large gauge wire, because it just becomes a more difficult task of soldering it on. So that's what we're going to do there. I also bought some ties with some sticky pads on them to secure the cabling as we work through the process. And here is the battery pack. So I actually got 2 of these. They're 10 amp hours, and I'm going to be wiring them in parallel. So I'll get 20 amp hours, and that's going to give me about, as I calculate here at 6 amps, it's going to be about 3 1/3 hours of full power to power the lights from fully charged to dead, basically. So, you know, I'll never use it that long, but I just want to have that extra capacity just in case. For the switches that I'm going to put into the trailer on the wall to turn the lights on and off, I'm going to try these residential home switches, 15 amp switches. I was looking at the little toggle switches, the micro switches typically used in trailers, RVs, but these tend to be more rugged. And the only issue with these is the space and the depth required. So if I can fit them in, I'm going to use them. And that's the first thing I'm going to do, is figure that whether these will fit or not. So a couple of notes I want to just mention to you about why I'm using this entire battery pack system here, instead of just putting in a normal battery. You know, I could put a larger 12-volt battery in and hook it up and bypass this charging circuitry here, which comes built in with these battery packs. And the reason I'm not going to put a battery in here is because if I was to do that, then there could be backflow of power. When the truck is disconnected, then if the battery is connected right into this junction point here, then this entire junction would always be energized when the truck wasn't connected, keeping that live. And it would also it could possibly drain down into this battery as well. So it would always be electrically connected. This charging circuitry here with the test and all that, fully charge, recharge, basically has a diode in it and prevents the power from going backwards. So once you disconnect the power here, the power cannot go backwards through this circuitry into this junction and keeping it alive the whole time it's sitting there. So that's why I'm using this charging package like you see here, instead of just a plain old battery. Okay, the other point I want to draw to your attention is these are 3-way switches. So because I want them to be able to turn on and off the lights at either end, so I need to have a 3-way. These are not simple single pole switches. Okay, so to check the depth of the wall, make sure the switches are gonna fit in the wall, I removed this dome light, just remove the 4 screws. I'm gonna use my calipers here that have a depth gauge to them, and I'm just gonna put it into this hole that was drilled for the wires and push it until it touches the back side of the wall. And you can see it's just about 2 inches, 21 millimeters, almost 2 inches. And we're going to just check that against the switch. And you see that if I was to put the switch in this way, I have plenty of room for the switch to have clearance on the back side of it. So I don't have to worry about the switch, you know, sticking out, hitting the back of the wall. So we're gonna go ahead and use these switches now. Before I go ahead and cut the holes for the switches, I'm going to make sure that there is nothing behind these walls like here. So when I look into here, I can see that this is all clear opening here, and that depth that we measured is consistent between these bays. I know that where the bays are because of where the manufacturer stapled the plywood on. So I think it's a lot like residential home construction, where it looks like every 16 inches they have some sort of beam, or stud, maybe aluminum, or maybe wood. And so that gives me confidence, along with the stud finder, which I use just to check. It seems like it's going to be okay to put a light switch here, right underneath this light here, about the same distance in, and then one over here. Now over here, I was getting some funky readings on the stud finder. It was staying on this whole way, so I was concerned there was some extra blocking in this area. So what I did was, I went out and I pulled out this air vent here, and I'm looking inside of it, and sure enough, it's all clear. There is a baffle here that seems to, oh, actually, that's not a baffle. That's the exterior aluminum of the trailer. So, and that is the vent on the outside. So it's consistent. The depth is consistent. And I removed a panel, which was right here, tied. It was just screwed to the wall like this. So I went ahead and I removed the screws of that panel, and I'm glad I did, because now I get a nice raceway for the wires. So I'm going to put a switch right about here, and I'm going to have the wires come out here, drill a hole through this metal iron here, and then come up and use this raceway. So that's going to make it a lot more easier for me than trying to snake the wire up through the wall. I have a nice raceway. Now for the height, we're going to do standard residential wiring. Switch heights are about 45 inches from the finished floor. Set at 45 inches from the finished floor. So that would put, and I made a little block, by the way. This is a 2x3 block, which represents the opening I want to cut out. So if I can line that block up with this edge mark I just did, which is the edge, the center of that hole right there above us, and then center it on a 45-inch height, which is right about there. And here's our first cutout. We're going to do the same to the other cutout. To cut the holes, I'm going to use my oscillating saw, and I think it'll be perfect for this application. So now it's time to get the wire, get a passage for the wire from this spot here, switch up to here, so I can run it along the top, and then back down as a switch for the three-way switching. So we have the two options. Like I said, it looks like an easier option would be using this raceway. I took this panel off here, and so I could easily just get the wire through here, and then up through there, and then we're all set. Now I notice here that this channel, this U-channel steel, it's about 1/8 inch thick steel, and the issue with that is that I don't really can fit a normal drill in, so I'm going to put this, try this carbide cutter here on a right angle drill, 3/8, and just try to work it in this way, as you see, and just kind of grind the opening of the hole. I couldn't use a normal twist drill because they're at least 5-6 inches, so I'd be out like this. Yeah, I couldn't get a good angle on it, so I'm going to try it this way. The other way would be to go back to our original plan and drill up through here to this top plate here, which is wood, by the way. So I could use a bit like this and stake it in like this, and I can feel hitting. I can put a drill on that and drill up through. But I'm very concerned about that because this sheet steel, sheet aluminum, that is the sheathing for the trailer, if it drifts at all against the backside of this wall, is that thin skin. So I'm very concerned that the drill is going to go through that, and then I've broken the weather seal on the shell. So I do not want to do that. I can't control that. This head wobbling around against that skin, so I've X-nayed that option. And I'm going to just work with the die bit, the die grinder. This bit here, it's a carbide die grinder bit, and we're going to do it that way. Okay, so I drilled the hole, nice 1/2 inch hole, using that die grinder bit. And so I penetrated through the steel, and I'm about, I have a 1/4 inch drill bit that I put through here all the way to the end of the stud. There's a stud here, 3.5 inches wide by 1.5. So I'm gonna finish the drilling with a wood bit. So if I was to use a normal wood bit like this, which has enough depth to penetrate through the 2.5 inch 2x3 in here, then it would work fine, but I can't get that in there. You can see how sharp the angle is. So to solve this problem, I went out and I bought one of these nifty little right angle attachments for a drill. And this is gonna allow me to put the bit in there like this, okay? So I already drilled it with this is a 3/8 inch bit, so I was using the grinder, the die grinder, to penetrate this far. So to finish it, I'm gonna go ahead and just use this right angle attachment now. And I just get enough room to put this in here. It's a push fit, so now look at that, it's perfect. So we're gonna just attach this to my drill, and we're gonna finish the hole this way, okay? With the holes cut for the switches and the hole drilled in the corner, as we saw, now we can start running the cable. So if you go back to my little schematic here, you can see that we have the 3-way switch here. There's one here, and we're going to use a 2x14 gauge wire, which I used in the house for speaker wire, so it's perfect for this application. And that's going to be connecting the toggles of the 3-way switches. And then what I'm going to do is I'm going to bring now it looks like it's on the floor, but actually it's going to be up here on the ceiling. I'm going to come up through here, using this hole as guide, bring it up like through this hole that's already there with this cabling up here, and then come back down here in the raceway, as you can see, in this raceway, and then come back down here, okay, and then into that hole I drilled. Now the toggle wire is routed, now we're going to just route the power wire. This is a 14 gauge single conductor solid copper wire, and we're just going to take off of this black wire here, which is the power the circuit for the auxiliaries powering this light. We're just going to run this power jumper down to the switch now. This will be powering the switch. Now on the other side of this switch now, as we set the power to that one, this one is going to take the light load. So we're going to do again the 14 gauge single conductor solid copper. And now what I did was, remember that hole I drilled through the steel? So to prevent any sort of tearing or cutting of the cabling, I went ahead and pulled out my grommet assortment kit here, and picked one of the grommets that looked like to be right size, which is going to be 7/16 diameter, and I'm going to use that. I want to see what that bushing looks like. It's right here, so it's very nicely tucked into the steel edge, and then the cables go through it. No worries there. With the switch cabling run now, I can now start to wire these the switches. So these are my toggle cables right here. You can see that they're stranded copper, so I'm going to go ahead and tin these, and I use the solid conductor for the power, which is going to go on the common screw.